Hello, everyone. It's me again, your virtual teacher, and we are back for another lesson. For today, we will do some work problems. Work problems have direct real life applications. We often need to determine how long it takes to finish a project, how many people are needed, and others. This video will focus on solving work problems that involve two persons and solving work problems that involve pipes filling up a tank. Let's begin. But first, we will discuss the general equation involving work-related problems. Most reference will give you this general formula. 1 over t sub b is equal to 1 over t sub 1 plus 1 over t sub 2 up to 1 over t sub n, where t sub 1 is equal to time for first person to complete the job alone, t sub 2 is equal to time for second person to complete the job alone, t sub n is equal to time for nth person to complete the job alone, and t sub b is equal to time if first to nth person will work together. By looking at this general equation, we can notice that this is also an expression of rate or ratio, since t sub 1, t sub 2, t sub n, and t sub b are in terms of time. In work-related problems, we can also express equation 1 as r sub b is equal to r sub 1 plus r sub 2 up to r sub n, where r sub 1 is equal to rate of first person to complete the job alone, r sub 2 is equal to the rate of second person to complete the job alone, r sub n is equal to the rate of nth person to complete the job alone, and r sub b is equal to the rate if first to nth person will work together. In the examples below, we will be using equation 2 to solve the problems. Sample work problem number 1. Catherine can paint a house in 15 hours. Dan can paint a house in 30 hours. How long will it take them working together? Our solution. Given rate of Catherine, which is C, is equal to 1 house over 15 hours, and rate of Dan, which is D, is equal to 1 house over 30 hours. So to find the number of hours if they work together, we will add Catherine and Dan's rate and produce a new rate R with X hours needed to paint one house. Therefore, transforming it into an equation, we will have C plus D is equal to R 1 over 15 hours plus 1 house over 30 hours is equal to 1 house over X hours. Checking for the less common denominator for the left side of the equation, which is 30, it will become 2 plus 1 over 30, which is equal to 1 over x. Simplifying, 3 over 30 is equal to 1 over x, and then rearranging, x is equal to 30 over 3, which is equal to 10. Therefore, it will take 10 hours to paint the house if Catherine and Dan will work together. Sample work problem number 2. Ivan can clean a room in 3 hours. If his sister, Faith, helps, it takes them 2 and 2/5 hours. How long will it take Faith working alone? Our solution, the given rate of Ivan to clean a room, E, is equal to 1 room over 3 hours. Rate of Faith to clean a room, which is F, is equal to 1 room over X hours. That is what we are looking for. And then the total rate if both Ivan and Faith cleans the room, R, is equal to 1 room over 2 and 2/5 hours. To find the time for Faith to clean the room by herself, we will add the rate of Ivan and Faith and equate it with the total rate if both will work together. So, E plus F is equal to R, Substituting 1 room over 3 hours plus 1 room over x hours is equal to 1 room over 2 and 2/5 hours, or simplifying, it will become 1 third plus 1 over x is equal to 1 over 12 over 5, which this right side of the equation will become 5 over 12. Transposing 1 third to the right side of the equation, it will become 1 over x is equal to 5/12 minus 1 third. Looking for the least common denominator, which is 12, it will become 5 minus 4 over 12 is equal to 1/12. Rearranging, x is equal to 12. Therefore, the hours needed for Faith to clean a room alone is 12 hours. Sample work problem number 3. A tank can be filled by pipe A in 4 hours and by pipe B in 3 hours. When the tank is full, it can be drained by pipe C in 2 hours. If the tank is initially empty and all 3 pipes are open, how many hours will it take to fill up the tank? Our solution, given the rate of pipe A, which is A is equal to 1 tank over 4 hours, the rate of pipe B, which is B is equal to 1 tank over 3 hours, rate of pipe C, which is C, is equal to 1 tank over 2 hours, and the rate to fill the tank if all pipes are open, which is R, is 1 tank over X hours. To find the hours to fill up the tank, we will just simply add the rates of pipe A, B, and C and equate it with the rate to fill the tank if all pipes are open. Notice the words filled and drain in the statement. Filled means it's adding into the tank, so it will be positive rate, while drain means it's reducing the content of the tank, so it will be a negative rate. So the equation will be A plus B plus C is equal to R. Substituting the values, 1 tank over 4 hours plus 1 tank over 3 hours minus 1 tank over 2 hours is equal to 1 tank over X hours. Looking for the least common denominator, which is 12, it will become 3 tank plus 4 tank minus 6 tank over 12 hours, which is equal to 1 tank over X hours. And then it will become 1 tank over 12 hours is equal to 1 tank over X hours. Rearranging, we can find X, which is equal to 12 hours. Therefore, it will take 12 hours to fill the tank if all pipes are open. That's it, everyone. I hope you were able to learn something new today. Don't forget your comments and suggestions on the comment section below. See you next lesson.